Hi guys, welcome back to another video. The topic for today is sequences and progression. We'll study this in two parts. Today we'll focus only on the progression side of it. Sequences we will look at the next part. Alright, so the topic that we will cover today is your basic arithmetic progression and geometric progression. Okay, now this topic is very easy. It's all formula based. If you know the formulas, you can solve all the questions quickly. Okay, however, having said that, there are certain concepts that if you learn or understand them, you can solve the questions even faster. Alright, or you can basically complement those concepts with your formulas and hence solve the questions very quickly. Alright, so without further ado, let's get into it. Alright, so let's start with arithmetic progression. Okay, if we think about it, AP, what is AP? Right? Let's think of an example. Say we have number 1, 4, 7, 10, 13, 16, 19, so on. Right? Now if I ask you what should be the next number, okay, if I ask you what should be the next number of the series, so what will you say? Correct, 22, right? Because we are adding 3, right? We are adding 3 to each number, right? After 22, 25, 28 and so on, right? Basically to find the next number, you just keep adding 3 again and again, right? So this is what an AP is. Let's take another example. Say 18, 16, 14, 12. Now what will be the next number? Correct, 10, 8 and so on. Now what is happening? You are decreasing each number by 2, right? You are decreasing each number by 2, right? And hence getting to the next number, right? The point we are trying to make, or the point we are trying to understand here is that, see, in any arithmetic progression, the important point is that the difference remains the same. Okay, you either add or subtract by the same value to get the next number. All right, the first number, right, this is called your A, which is your first number, or A1. All right, this difference, right, this is called D. Okay, this difference is called D. Now if I just tell you find the next number or third number from now, fourth number from now, all that is fine. You can just write it down or calculate it orally, right? But what if I ask you, tell me the 100th number, right? This is the series, tell me the 100th number of the series. Now we can't write and solve, right? Now we can't orally calculate and solve, right? So question comes, then what do we do, right? So that is where your formulas, basic formulas come into picture, right? See, any arithmetic series is written by the first term, which is A or A1, whatever you want to call it. Second term is A plus D, because the common difference gets added to it. Then A plus D, right, which is A plus 2D, then A plus 3D and so on. Now if you observe, see, for the second term, we added D once. For the third term, we added D twice. For the fourth term, we added D thrice. So what will happen for the 10th term? For 10th term, we will add D 9 times, right? Similarly, for 20th term, we will add D 19 times, right? So if you understand that logic, right? So what will happen for the nth term? We will add D n minus 1th time, right? See, for third term we added twice, for fourth we added thrice. So going on that basis or on that logic, for 10th term we added it 9 times. So for 20th term we will add it 19 times, right? So similarly, if there is nth term, right, we will add it n minus 1 times, right? Now a lot of us get confused that what is this n, right? Why do we write it? So see, as I said, the first term you can write it as A1 also, or A, right? The second term, right? The second term, right? First term can be written as A1, then second term will be written as A2. A2 tells you that it is the second term of the series. A3, A4, A10, A20, right? So this n tells you what term number it is, Okay, so nth term, right, an will tell you that this is nth term of the series. All right, so this is a basic simple formula that can help you tell what term number it is, or what if the term number is given, what is the value of that term is. Okay, let's look at the example. So the previous series that we did, 1, 4, 7, 10, 13. Now we all know the next number is 16, correct? This is first, second, third, fourth, fifth, sixth term, right? This is A, right? The common difference D is 3, right? Now if we have to find the sixth term, right, using the formula, A6 is A plus N is actually 6, so 6 minus 1 into D. If you do, A is 1, 6 minus 1 is 5, D is 3. So if you solve it, that's 15 plus 1, 16. So you know A6 is 16, right? So this is how your formula works. So whenever a term number is given and they ask what is the value of it, you can simply apply this formula. Similarly, the other way around, what if they give me the value and they ask what is the term number, right? So I know this is sixth term, this is seventh, so this is 8. Now they tell me that one term of this series is 22. I don't know what term number, I'm supposed to find that. So then I will write an is 22, right? An is a plus n minus 1d, that is 22, because the term value is 22. I need to find this n, right? 1 plus n minus 1 into 3 is 22. 1 goes there, n minus 1 times 3 is 21, n minus 1 is 7, n is 8, right? N is 8. Okay, so this is how we understand or we figure out the term number or the term value. All right, if we understand this, then the question comes, all right, you understand what is the term number, how to find that. Then the next step comes, sum of the terms, right? What if I want sum of all of these terms? I don't want to know individual values, I want to know sum of all of these. Okay, so then we simply use the formula, sum of n terms is n by 2 into 2a plus n minus 1 into d. Okay, that is n by 2 times 2a plus n minus 1 into d, or n by 2 first term plus last term. Okay, or you can simply write sum of n terms is n by 2 into first term plus last term. Okay, let's look at it. So we have, again the series was 1, 4, 7, 10, 13, 16, right? Now if I just add all of this comes out to 51, right? Now these are, I know, 6 terms. So if I want to find the sum of 6 terms, right, I'll simply write 6 by 2 into 2 into 1, because a is 1, plus 6 minus 1 into 3, right? That is 3 times 2 plus 15, 3 times 17, 51, right? At the same time, if I already know that the last term is 16, so I can also do sum of 6 terms, right? Sum of 6 terms, right? Sum of 6 terms is 6 by 2 first plus last, right? That's 3 times 17 again, that's 51. Okay, so this is how we use the formula for sum to find the total sum of the values. Okay, now one interesting thing, guys, that we can observe here, right? One interesting thing that you can observe from here, right? We have done averages, right? Averages is total sum by total number, right? So what is total sum equal to, right? Total number into overall average, right? What is total sum equal to? Total number into overall average. Think about it. sum average is sum by total number is equal to average. So what is sum? Average into total number, right? If I just follow that here, total number I know is n times average is n by 2 into first plus last, right? N and n cancels out. What does this give me? Average is first plus last by 2, right? So let's get into more depth of this, right? What we are trying to understand, or what is our takeaway from here, that okay, we understand these formulas. Next point is average, right, or mean, right, the arithmetic mean of a series. Now we know average is given by the formula total sum by total number, right? If any generic series is given, if any random values are given, this is how we find average, right? We have already covered the average in previous video, right? That is how we find average, right? But what if the series is an arithmetic progression, right? What if the series is arithmetic progression, right? So in an AP, right, average will become total sum. Total sum is n by 2 times first plus last, right, whole divided by n. N cancels out. It becomes first plus last by 2, right? So point being that if it is an arithmetic progression, right, the average of the series is simply the first term plus the last term by 2. Okay, now that we have covered statistics, another takeaway from here, in an arithmetic progression, right, mean is equal to median, right? The average is the middle term also, right? Which kind of makes sense, right? Because see, if your values are 1, 4, 7, 10, 13, 16, 19, right? You look average 1 plus 19 by 2, right? Average will become 1 plus 19 by 2, which is 10, which if you see is the middlemost term also, right? Now why does it make logical sense? That see, after 1, how do you get the next number? By adding 3. Now before 19, how do you get the previous number? By subtracting 3. So if I look at these two, I have added 3 and subtracted 3. So when I add, the net difference is 0. Similarly here, I have added 3 again, subtracted 3 again. So 7 plus 13 is again 20, right? 4 plus 16 is again 20. 1 plus 19 is again 20, right? So the point I am trying to make is that in an AP, mean and median are same. That is, average is your middle term itself, okay? And the sum of first and last, second and second from last, third and third from last will remain constant, okay? Right? So now, if you have, right, based on this, what do we learn? That if there are only two terms, average will become a plus b by 2. If there are three terms, average will become a plus b plus c by 3. Or if there are multiple terms, right, average can simply be first plus last by 2, as long as those terms are in AP, okay? Moving to the question, so we have, right, a sequence is defined as a1 is 5. See, the pattern is given, an is equal to an minus 1 plus 7. What does this tell you? That the nth term is equal to the previous term plus 7. Now since each term is previous term plus 7, we know this is AP, right? Because of this, we know this is AP, and we want sum of terms from A15 to A23, right? Now as I said, all the questions of this topic can be done by formula, right? We know that first term is 5, right? And nth term is an minus 1 plus 7. So an is equal to an minus 1 plus 7. If n is 2, right? If n is 2, right, we have a2 is equal to a2 minus 1 plus 7, which is a1 plus 7, 12, right? So a1 is 5, A2 is 12, and so on. And we know this is an AP, right? Now the question is, we want sum of all terms from A15 to A23, right? So one thing we can do, right, is we find what is A15, right? One thing we can do is, you think about what is A15, right? A15 will be A plus n minus 1 into D, so that is A plus 14D. A is 5, right? D is 7, so 14 times 7, that's 103, right? So we have A15. Simultaneously, we find A23, okay, that will be A plus n minus 1 into D, so 5 plus 22 into 7, right? That will be 5 plus 22 into 7, 159, right? And now from A15 to A23, how many terms are there, right? Those are 9 terms, right? A15 to A23, if you count the number of terms, these are 9 terms. So sum will become, right? Now this series is the question that they are asking. The series is A15, A16, A17 till A23. So the first term of that series is A15, not 5, because they are asking from A15 to A23, right? So A15 is 103, 110, so on till 159, and these are 9 terms in total. So the sum formula, right, sum of these terms will become, that's n by 2 into first plus last, right? That is 9 by 2 times, right, 103 plus 159, that is 9 by 2 times 262, that's 131 into 9, right? If you solve this, that is 131 times 9, that's 1179, right? So this is your theoretical way to solve. Now as I said, that if you understand the concept, right, you can solve these questions even faster, right? So question comes, how do I solve that, right? How can I solve this much faster, right? I can do this, this is easy, but it takes time, right? So what can I do? So see, we know sum is average into total number, right? Sum is, right, if I just write here, sum is equal to average times total number. I know total number is 9. These are 9 terms. A15 to A23 I can calculate. These are 9 terms. Now question comes, what is the average? I know in an arithmetic progression, average is the middle term. From A15 to A23, if you just count, what will be the middle term? That will be A19. The 19th term will be the middle term because it will have 4 terms before it, 15, 16, 17, 18. 4 terms after it, 20, 21, 22, 23. So A19 is my middle term. Now that you know A19, we know that is A plus n minus 1 into D, right, times number 131 times 9, 1179, right? So the point is, you can either apply the formula, find A15, find A23, apply everything and solve. That is one way to go. Or you can simply, right, you can simply apply the concept, make life easier for you. We have to apply the formula then also, but at least we are applying it fewer number of times and getting the answer quickly. Okay. Alright. Moving on to the next one. So we have a sequence of consecutive integers, right? Sum is given, first term is given. They are asking how many integers are there in the sequence, right? Now since these are consecutive integers, right, what will they be, right? If the first term is 6, consecutive, will second term will become 7, 8, 9 and so on, right? This again looks like an AP, right? This also looks like an AP, right? Now I have sum of n terms. Now since I do not know the last term, what will I do? I'll use the first formula, right? See, there are two formulas. It is upon me which one to use. The second formula can be used only if I know the last term. Here I don't know the last term, so I'll use the first one. That is n by 2 times 2a plus n minus 1 into d, right? Sum is given as 105. Number of terms is what they are asking. 2 times 6 plus n minus 1 into 1. Right, this 2 goes there. 210 is equal to n times 12 plus n minus 1. Right, 210 is equal to n square plus 11n. Right, this implies n square plus 11n minus 210 is 0. Simple quadratic equation, plus 21 minus 10. Right, if I solve this, that's n minus 10 times n plus 21. Right, either or n is 10 or n is minus 21. Its sequence of numbers cannot be negative. N is 10. Right, its sequence of numbers cannot be negative, hence n is 10. Alright, moving to the next one. Right, what do we know? Again, the arithmetic series, nth number, nth term is the previous term plus r. So from this we know this is an AP, right? And now we know average of Q6 to Q10. Okay, average of Q6 to Q10 is 22. Okay, and Q5 we know is 10. What is the value of Q4? All right. Now, average of Q6 to Q10 is 22. Now, we just did this in a couple of questions back when we did A15 to A23, right? If it is Q6 to Q10, don't start again solving for sum of Q6 to Q10, right? Think Q6 to Q10 are 5 terms, okay? Q6 to Q10 are 5 terms. They are all in AP. Average will be the middle term. Now, from Q6 to Q10, the middle term is what? Q8. So, we know Q8 is 22. Okay, so from this we know Q8 is 22. Okay, and we also know Q5 is 10. Right, again we know Q5 is 10. Right, now one way to solve, right, like good people, right, or like good students, we apply the formula. Q8 is A plus 7D is 22. Q5 is A plus 4D is 10. Subtract, right, you get 3D is equal to 12, D is equal to 4. Plug it back in. A plus 7 times 4 is 22. A is minus 6. Get the first term. What are they asking? Q4. Q4 is A plus 3D. Minus 6 plus 3 times, 4. Right? That is minus 6 plus 12, 6. Right, one way is to be a good student, write everything down and solve. Right, another way is to be lazy. Right, see, you know Q8 and Q5, how many, what is the difference here? 3 terms, right? Q8 and Q5, what is the difference? 3 terms. How do I go from Q5 to Q6? I add a D. From Q6 to Q7, add another D. Q7 to Q8, add another D. So if I just directly subtract, I know the difference between these two is equivalent to 3D, right? Because Q8 and Q5, these are 3 terms. They are 3 terms away from each other. So the difference will be directly 3D. You know D is 4, right? Alright. Now you will say, sir, again D is 4, again we need to plug it in formula. No. Q5 is 10, D is 4. So what will be the previous term? Minus 4. See, when we go ahead in AP, we keep adding D. If I want to go back, what will I do? Subtract. So Q4 will directly be Q5 minus 4. Right? Q5 minus D, which is 10 minus 4. Right? So again, see guys, the point is you can learn formulas, you can solve questions step by step. There is absolutely nothing wrong in that, no harm in that, right? You do this way and you get a good score, I have absolutely no problem, right? But what we are trying to do is learn concepts so that we can solve the same question in a much faster manner. Okay? Again, moving to the next one. So we have sum of first 30 terms is 750. Sum of next 30 terms is 1350. Question is, what is the common difference? Right? Okay. So sum of first 30 terms is 750. So what will we write? S of 30 is 750. Right? Now, interesting point. Sum of next 30 terms is 1350. Okay, what does that tell you? That it's not, okay, what does that tell you? That it is not that from beginning till 60th term, right? See, this is term number 1 to 30. This is term number 31 to 60, right? So sum of 31 to 60 is 1350. Okay, which means if I add the two, if I add these two, sum of 1 to 60, which is sum of first 60 terms, is 750 plus 1350. That's 2100. Okay, does that make sense? Right? Remember, this is sum of next 30 terms, right? Not the original, the next 30 terms. Okay, now you can again apply formula. So you have 30 by 2, right? 30 by 2 into 2a plus 30 minus 1 into d is 750, which means 15 times 2a plus 29d is 750, right? 2a plus 29d is 50, right? That's equation number 1, right? This is for S30 equal to 750. Similarly, if I solve S60 is equal to 2100, right? That is 60 by 2, 2a plus 59d is 2100, right? If I solve that, 2a plus 59d, right, is 70. Equation number 2, right? Now what do I do? Subtract the two equations, right? Subtract 1 from 2. 2a cancels out, right? If I subtract, what will happen? 2a will cancel out. 59 minus 29, 30d is 70 minus 50, 20. D is 2 by 3, right? D is 2 by 3. Okay. I know you are waiting for something, right? This time you are waiting that, okay, what can be the faster way, right? I understand that, right? Yes. Let's look at a faster way then. Again, apply logic, right? Again, apply logic. Sum of first 30 numbers, okay? Sum of first 30 numbers. What is that? That is A1 plus A2 plus A3 till A30, right? That is sum of first 30 numbers. What is sum of next 30 numbers? That is A31 A32, A33 till A60, right? And we know each number is D more than the previous one, right? So if whatever is A1, A2 is A1 plus D, A3 is plus 2D, right? Right? So each term is D more than the previous one, correct? Now if I subtract the two, right, this I know is 750, this I know is 1350, right? If I directly subtract the two, A31 minus A1, there is a gap of 30 terms. Think about it, from first term to 31st term, what is the gap? The gap is of 30 terms. So the difference between this will be 30D, right? Difference between A31 minus A1 will be 30D. Similarly, A32 minus A2, again the gap is 30 terms, again 30D. 33 minus A3, again 30D. A60 minus A30, again 30D. 1350 minus 750 is 600, right? How many times is this added? 30 times. So 30 times 30D is equal to 600. D is equal to 600 by 900, which is again 2 over 3, right? Remember, arithmetic series or progression is a fixed progression, right? So if you understand how it works, you can solve the same question in a much faster manner, okay? Alright, moving on to the next one. So we have 6 times the 6th term is equal to 9 times the 9th term. Okay, let's just write this down. 6 times A6 is equal to 9 times A9. Okay. Alright. And then we need 15 times A15. We need 15 times A15. Okay. So let's just solve this. Right. What is 6th term? A plus 5D. What is A9? A plus 8D. 6A plus 30D is 9A plus 72D. Get everything on the same side. 3A plus 42D. Right, take 3 common. A plus 14D. A plus 14D is 0. Right. Now what is A plus 14D? That's the 15th term. Right, what is A plus 14D? A plus 14D is actually the 15th term. So what we get? The 15th term is 0. So if 15th term is 0, 15 times A15 will be 0. Right, 15 times A15 will be simply 0. Alright, another interesting question. Right, so we have a set of colored balls and the color order is this: yellow, blue, green, red, white and so on. Now we know the 19th ball is green, right? We don't know what the first one is, but we know the 19th ball is green, right? What color will be the 567th ball, right? So again, right, the first color ball, I don't know what it is, right? That is, say, my A1, which is of some color, right? Then A2, then A3, then A4, A5, and post 5 the same color repeats, right? The same color repeats. The 6th ball is same as the first ball, right? The color of the 6th ball is same as color of the first ball, right? So I know that my values repeat after 5. So basically that becomes my common difference, right? That becomes my common difference. So if I know 19th ball is green, right, that means A19 is green, right? A19 is green. I know the common difference is 5. If I simply divide 19 by 5, right, if I divide 19 by 5, I get remainder as 4, right? That means the fourth ball has to be green, right? How do I get it? See, if A19 is green, 5 before it, A14 will be green, 5 before it, A9 will be green, 5 before it, A4 will be green, right? So we get to know that if A19 is green, A4 is also green. So if this is green, right, if this is green, right, and I know they follow this order, so the one after green will be red, right, the one after green will be red, right, one after that is white, so the first ball is actually white, right, one before green, right, one before green is blue, right, and the one before that is yellow. So this is my order. First color is white, then yellow, then blue, then green, then red, right, and so on, right. Now the question is, right, what is the 567th ball? Again, I know after every 5 values they repeat. So what do? I simply divide 567 by 5, right? I get 113, that's 565. 2 as my remainder. That means this is the quotient. That means 113 circles will be completed. Okay, this will be my 565th ball. Okay, this will be my 566th ball, 565th ball, right? 113 circles are completed, right? I need to take 2 more steps, right? I need to take 2 more steps. So this is my 565th ball. This will become my 566th ball. This will become my 567th ball. Since the remainder is 2, I just look at ball number 2, right? So I know 567th ball is yellow. Now moving on to the next type of series, that is geometric progression, right? Moving on to the next type of series, that is geometric progression. Now what happens in a geometric progression, right? The same number gets multiplied again and again. See, in the previous one, arithmetic progression, we were adding the same value again and again, right? Whereas in a geometric progression, what do? We keep multiplying by the same value again and again, right? So say the first term is a, right? The second term will become a into r. Third term will become ar square, ar cube, and so on. Okay, let's look at an example. Say the first term is 2, second term is 6, third is 18, then 54. Now can you tell me the next term? Right? Think of what will be the next term. See what is happening. We are multiplying by 3 again and again. The next term will be 54 into 3. That's 162. After that, 162 into 3, 486, and so on. Right? So what is the parallel and what is the difference between the two? So see, the first term is a, which was there also. There we were adding 3 again and again. Here if you see, we are multiplying 3 again and again, right? To find the next term, we are multiplying by a common number, right? So that first term, which is also called a, is 2 in this case, right? Then the multiplying factor r is 6 over 2 or 18 over 6 or 54 over 18, which is 3. Just divide any two consecutive term and you get the value of r. Okay. Alright. Again, if you understand this, then again let's get into the formulas, right? Say the series was 2, 6, 18, 54, 162, 486, right? This is my first term. For second term, what am I doing now? I am multiplying by r once. For third term, what am I doing? Multiplying by r twice. For fourth term, multiplying by r 3 times, right? So similarly, for nth term, what will I do? Or 10th term, what will I do? I will multiply by r 9 times. For 20th term, what will I do? Multiply by r 19 times, right? So for nth term, what will I do? I will multiply by r n minus 1 times, right? For second term, we multiplied 1 less 1 times, right? There we had n minus 1 was multiplied by d and added to it, because in AP you add the number again and again. But in GP, because we multiply it again and again, right, it goes in power because you are multiplying again and again, right? The concept remains the same, okay? Application of formula remains the same. It's just that the answer changes because the series are different, okay? Again, let's take an example. Say I know 1, 2, 3, 4, 5. Sixth term is 486, right? I know sixth term of the series is 486. If I say, okay, nth term of the series is 486, right? Tell me what is n. So I will write a into r power n minus 1 is 486. A is 2, which is the first term. R is 3, right, is 486. 2 goes there. 3 power r minus 1 is 243. 3 power r minus 1 is 3 power 5. Since bases are same, we equate the powers. R is 6. Right? If you do the corollary of this, if they ask what is the fifth term, so fifth term will be a into r power 5 minus 1. A is 2, r is 3, 5 minus 1 is 4. 3 power 4 is 81 times 2, 162. So fifth term is 162, right? So this is how you apply the formula. Now, the way we had right, the sum formula there, similarly we have a sum of n terms formula. Okay, sum of n terms of a series is simply given by a times r power n minus 1 by r minus 1. Okay, sum of n terms of a series is simply given by a times r power n minus 1 by r minus 1. Okay, if you look at the same series, that's 2, 6, 18, 54, 162, right? If I add all the terms, it's 20, 60, 80, 242, right? If I add all of it, I get 242. Alright, now if I apply the formula, these are how many terms? 5 terms. Sum of 5 terms is a, which is 2, r is 3 power 5 minus 1 by 3 minus 1. That's 2 times 3 power 5 is 243 minus 1 by 3 minus 1, which is 2. 2 and 2 cancels out, 242. Okay, so the way we have sum formula there, same way we have a sum formula here. Okay, now interestingly, let's see, it is not necessary that in a GP I only multiply by a bigger value, right? I can also multiply by a fractional value. See, the way we had in arithmetic progression, you can add or subtract, right? Similarly here, why do you multiply always by an integer? You can multiply by a fraction, or you can, in other words, divide by a number, right? Divide by an integer, right? So in such series, right? Okay, what are these series? Where r is less than 1. Okay, in such series, right? Again, if you look at it, some formula will become a into r power n minus 1 by r minus 1. Okay, right, let's look at, right, the reverse of the previous series, right? We have 162, then 54, right, then 18, 6, 2, and so on. Right, now a1 is 162, r is 1 by 3. So series when r is less than 1, right, this will become negative, and r power 1 n is also less than 1. So you can just tweak the formula to a is, right, nothing changes, it's just the same formula. I've just multiplied both by minus 1, right, so that both become positive, that's all. Right, now this is where things get interesting, right? What if this series does not stop? What if I have infinite terms? So what will happen? Sum of infinite terms, in place of n I am putting infinite, that will become a into 1 minus r power infinite by 1 minus r, right? Now r is a fraction. The higher the power, the lower the value, the closer it gets to 0, right? So if I do infinite, this particular term simply becomes 0 because it becomes closer to 0. See, 1 by 3, right, is 0.33. If you square it, that's 1 by 9, that's 0.11. The value has decreased, right? The value has decreased. So then what happens? So if you have infinite terms, right, and r is less than 1, 1 minus 0 by 1 minus r, sum of infinite term becomes a over 1 minus r. Okay, so if there are infinite terms in a series, right, then the only way you can find sum is condition number 1, r should be less than 1, and second, right, then sum becomes a over 1 minus r. Okay, alright, if you understand this, then some generic points about GP. So see, the way we did arithmetic mean, what was arithmetic mean? Right, it is average, right, because it was an addition series. For 2 numbers it is a plus b by 2, for 3 numbers it is a plus b plus c by 3, and so on, right? Now in a GP, because it is a product, right, because it is a product, we keep multiplying by the same number again and again, right? So geometric mean of 2 numbers will become ab power 1 by 2, that is square root of ab. Okay, so if you have 2 numbers, then the geometric mean becomes square root of ab. If you think about it, right, if you just deviating from the topic, if you think about it, this is what we did when we did mean proportion, right? If you think about the mean proportion, right, what was it? X by y is y by z. If you think, this is what? Common ratio. This is what? Common ratio, right? What was the middle term? X into z is y square, y is square root of xz, right? And we call this the mean value, right? This is what it is, right? The mean proportion. Okay, similarly if we just continue, so if there are 3 terms, that will become power 1 by 3, essentially cube root of abc. Okay, so this is how we find geometric mean. All right, and super important point, this helps when questions of maxima and minima come. For any series, am is greater than equal to gm. Okay, right, this is like super difficult question, minima maxima question. If they come, remember arithmetic mean of 2 numbers is always greater than equal to geometric mean. Okay, we'll apply this when we do algebra. Okay, I'll remind you there as well, we'll apply this when we do algebra. Okay, all right. Okay, it's the same series that we just did, right? That is, the sequence is 2, 6, 18, so on, right? Nth term is given by previous term into 3. This gives us that this is GP. because each term multiplied by the previous term into 3, this tells us that this is 3p. Now question is, by what percent is the 10th term greater than the 8th term? Right, 10th term greater than the 8th term, right? So again, percentage greater will be A10 minus A8 by A8 into 100. The percentage by which A is greater than B is given by A minus B by B into 100. Now A10 is what? A into R power 9, right, minus A into R power 7 by A into R power 7 times 100. Okay, now if you want, you can put the values, or you can just simplify here itself. See, take A common, cancel. You can take A into R power 7 common. R square minus 1 by A into R power 7 times 100. This cancels out. Now you can plug in. What is R here? 3. 3 square minus 1 times 100. That's 800. Okay. So this is how you can do by using formula. Or like we did the previous topic, can we do it quickly? Yes. See, each term is previous term multiplied by 3. So A10 will be 3 times A9. A9 will be 3 times A8, right? That means A10 is 9 times A8, right? You don't even have to solve all this. Just think logically. A10 becomes 9 times A8. So that is how much greater? 800% times, because A10 is 900% of A8. So how much greater? 800% times. Alright. Now we have sum of first 10 terms is equal to sum of first 12 terms. Okay. Alright. No problem. We simply write it down. Sum of first 10 terms is equal to sum of first 12 terms, right? If we apply the formula, A into power 10 minus 1 is equal to A into R power 12 minus 1 by R minus 1, right? We simplify this, A and A cancels out, R minus 1 cancels out. We get R power 10 minus 1 is R power 12 minus 1. Minus 1 also cancels out, right? R power 12 minus R power 10 is 0. R power 10 common. R square minus 1 is 0. Remember, never cancel the variables. We have done this in absolute values, right? Never cancel the variables. Now if we divide, if we simplify this, R power 10, R plus 1 into R minus 1 is 0. R is either 0, plus 1 or minus 1. Right, R is equal to 0, plus 1 or minus 1. Now what do we know? We know sum of first 15 terms is 150. Right, that also we know. Sum of first 15 terms is 150. Now, right, S15 is 150. Correct? S15 is 150. Right? If R was 0, won't all the terms become 0? Right? If R was 0, won't all the terms become 0? Right? The first term will remain this, but all the other terms will become 0. Right? So probably, right, looking at the options, right, R shouldn't be 0. Right? So then we have sum of 15 terms as given by the formula A into R power 14 minus 1 by R minus 1 is 150. Now if R, okay, if R was 1, the denominator becomes 0, right? If r was 1, the denominator becomes 0, again, which is not allowed because denominator can never be 0. This becomes a not defined number, right? Right. So r has to be either 0 or minus 1. Okay, r has to be either 0 or minus 1. Plus 1 has been rejected, right? Now if r is two cases, right? Now we can take two cases, right? Sorry, r cannot be 1, right? Now we take two cases, either r is 0, right? Either r is 0 or r is minus 1, right? These are the two cases that we look at. If r is 0, this tells you that a into 0 minus 1 by 0 minus 1 is 150. A is equal to 150, right? So the first term becomes 150 and all the other terms, right, in this series, first term is 150 and all the other terms are 0 after that. Okay, then a4 will also be 0, right? Or else let's look at the second scenario when r is minus 1. Then we have a into, my bad guys, a into, sorry, I made one mistake, this should be 15, right? The sum formula is, this should be 15, right? A into r power 15 minus 1 by r minus 1 is equal to 150. If r is minus 1, right, if r is minus 1, a into minus 1 by minus 1 is 150. Again a becomes 150. Okay, again a becomes 150, right? So the first term will become 150, r is minus 1, so second term will become minus 150, third will again become 150, fourth will again become minus 150, right? Since 0 is not an option, we have to take r as minus 1 and the answer becomes minus 150. Okay. Alright. Again a simple question. Sum of infinite terms is 20. First term is 10. What is the fifth term? Now we know for infinite terms the condition is r has to be less than 1 and we know sum of infinite terms is 20. A is 10. Sum of infinite term formula is a over 1 minus r, which is 20. 10 by 1 minus r is 20. 1 minus r is half. R is half. So we know the common ratio is half. What do we want? The fifth term, which is a into r power 4, right? Because it is n minus 1. 10 into half power 4. 10 by 16. That's 5 over 8. Right? So again you guys will realize that, see, all the questions from this topic are all formula based. Okay. Right. All right. Interesting question. So you have an investment. You start off with $2,000. Interest rate is 6% compounded annually. Deposit amount for 2 years. Total interest earned in 2 years. Right. Now, if you read it, you will realize that this is a compound interest question. Right. This is a compound interest question. Now, if you think again, right, if you understand the concept, you will understand, right, or you can realize compound interest, right, is nothing but GP, right? The amount in case of compound interest, right? See what will happen here? The amount increases by 6% every year, right? So if my first year value is principal, what is my second year value? Principal into 1.06, because it increases by 6%. What is my third year value, right? Or value after 2 years? The previous value again into 1.06, because this value again increases by 6%. So ultimately what I'm trying to say is that amount in case of compound interest, okay, simply follows a GP. Okay, it simply follows a GP, right? So if we find amount, right? So if we find A3, that is A1 into R power 2. Okay, guys, if you understand this, great. If you don't, no problem. You can apply the compound interest formula and solve. There is no harm there. Okay, this is just a different way because we are doing APGP. So I just thought that I'll teach you this using GP. Okay, A1, which is your principal, into, it is increasing by 6%, right? Right? Now we'll learn this, okay, when we do calculation tricks. We'll have a special video wherein I'll teach you how to do calculations quickly, right? For now you can just trust me on this, right? So that is 2 times 1123.6 2247.2. remember, this is amount. Okay, this is amount. So what is the interest earned? Amount minus principal. What is the interest earned? Amount minus your principal. Okay, so take away, in compound interest the amount simply follows a GP. Okay, right. A nice question here. We have, right, the values A, B, C, D are all equally spaced, right? They're all equally spaced of each other, right? C is 3 power 12, D is 3 power 13. Okay, let me just draw this here. This is A, B, C, D, right? A, B, C, D, right? 3 power 12, 3 power 13. They say they are all equally spaced. Equally spaced means this should be an AP, not GP, right? The difference here is same as difference here, same as difference here, and so on. Okay. Now you might be tempted, right? You might be tempted, okay, to say that okay, this is 3 power 13, 3 power 12, equally spaced, so 3 power 11, 3 power 10. No, right? No, that this is not equally spaced. Okay, this is exponential spaced, right? This is not equally spaced. The difference between these two is not same as the difference here. Okay, so doing this, right, or falling into that temptation will make us go wrong, right? Instead what you can do is, right, instead what you can do is, see, look at the lowest value in the entire graph, that is 3 power 12, right? That is 3 power 12. So let's do one thing. Let me divide the whole graph, all the values, by 3 power 12. Okay, what do? I am dividing all the values by 3 power 12. So this I any which ways don't know. This I don't know. Divide by 3 power 12, this becomes 1. Divide by 3 power 12, right? This becomes, right? This becomes plus 3. Okay. All the options are also, right, divided by 3 power 12 as of now. Okay. Now let's focus on equally spaced. What do we mean by equally spaced? The distance should be same. This is plus 3, this is plus 1. So there is a gap of 2. This is plus 1, so this should become minus 1, right? Because there is a gap of 2, plus 1 should become minus 1. This is minus 1, again gap, so this should become minus 3, right? This is the meaning of equal spaced. Okay, but this cannot be my answer. Why? Because I have multiplied everything, divided everything by 3 power 12. So in order to bring the values back to their original value, what do? I go back and multiply each term by 3 power 12. Okay, I multiply each term by 3 power 12 again. Okay, so what does this leave me with? So this is again 3 power 13. This is 3 power 12. This is actually minus 3 power 12. And what is this? Minus 3 into 3 is minus 3 power 13. Okay, so this is actually minus 3 power 13. Okay, I hope you understand this, right? Don't fall into the trap that okay, 3 power 13, 3 power 12, so 3 power 10, 11, 3 power 10. Okay, don't do that. Don't mark this. Right. Alright guys, that brings us to the end of this video. I hope you were able to understand the concept of APGP and perhaps learn a simpler way to solve these questions. Okay, I understand we all know the formulas, we can apply them. The point is that can we apply some concepts, easy concepts, to help us solve the same questions but in a faster manner. Okay, I hope we were able to achieve that in this video. Right? Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and tried to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.